Hello everyone, my name is Yu Zhou. I'm the instructor of ECE 235 in this 2020 spring semester. I joined SBSU ECE department back in 2012 fall and has been working here for a while. My office is at Pioneer Hall 211. And today we're gonna start to learn the module 1, circuits, elements, and combinations, and which is also our very first topic regarding the circuit knowledge. And this module will cover the following things. First, we will talk about the basic electrical quantities and units. And then we will talk about the basic elements could be involved in the circuit. Next, we will talk about their basic combinations, or say the connections, and resulted relations. At last, we will go through some examples to see how well we understand the material we learned. Okay, so now let's get started. 1. Basic electrical quantities and units. There are some very important and basic terms, or say concepts, we need to become familiar with. The first one is electrical charge, represented by letter Q. The unit is coulomb, represented by C. So Q in C. It is one of the basic physical property of a particle. So with this charge, we can have current flow. So current I in ampere, capital letter A, it is a rate of change of Q expressed by this mathematical differential equation. Okay. Derivative of Q of t with respect to time t is equal to the current. The next is voltage, very frequently used term. V as the voltage in unit of volt, capital V. The voltage is an electromotive force, or say potential, between 2 points. Here, you need to keep very strong understanding in your mind that the voltage is and always talking about 2 points, the difference potential between 2 points rather than 1 point. Okay, and with this potential difference, it's gonna push the charge flow from the high potential point towards the low potential point, therefore forming a current. Of course, in the motion of the Q, we have resistance, which is another term we're going to talk about in future. The next concept is called work or energy. From the electrical engineering standing point, we use energy much more often, but it means the same as work. Okay. Capital letter E, unit of joule. Energy is introduced by the motion of charge, implementing an energy transfer between two systems or two elements. And next, power. This is a very, very important concept in electrical engineering circuits, okay, because it is expressing a rate of change of energy. It's talking about the derivative of energy with respect to the time t. Could be simply calculated by the product between voltage across the element and the current through it. Okay, these are the basic concepts. With them, we keep talking about the quantities and units here. So here, let's talk about, or say review the prefix. No matter what kind of units we're gonna use, we always could come across these prefix as part of the quantities. So 10 to the negative 12 to 10 to the positive 12. So 10 to the negative 12 is called pico, lower p as prefix. 10 to the negative 9, we call it nano, lowercase n as prefix. Next, micro, lowercase mu as prefix. And this is milli, lowercase m as prefix. And 10 to the 0 is equals to 1. So it is just a SI unit without any prefix. Next, kilo, uppercase K as prefix. Then mega, uppercase M. And then 10 to the positive 9 is giga, uppercase G. Last one, 10 to the positive 12 is tera, capital letter T as prefix. Of course, there are more prefix in SI units. However, these should be enough to cover everything we possibly come across in future electrical quantities. Okay, with those being said, now let's talk about more concepts. I want to emphasize current direction, voltage polarity, and the power sign. 3 things. Okay, making you realize that the voltage, current, power as the most commonly used electrical quantities, they have direction, polarity, and the sign issues, in addition to the magnitude. So let's start with the current direction. So current direction, the most important concept here you need to realize is this. So one direction with positive current value is equivalent to the other direction with negative current value. For example, we have a current flow from left to right. With this direction, the current is given as positive 10 ampere. Which following ABC is equivalent to this case? A, the current from left to right remaining with current value of negative 10. Obviously, this is not right, not equivalent. B, current from right to left with positive 10 ampere as current value. No, not the equivalent either. How about C? C is from right to left, which is opposite direction to the given one here. However, the current value is given as opposite sign, negative 10 ampere as well. So C is the equivalent scenario for the given current. Similarly, in voltage, we have polarity issue. So one polarity with positive voltage value is equivalent to the opposite polarity with negative voltage value. Again, another example. So if we have voltage given value of 10 volts, positive 10 volts, however, the polarity is positive here, negative here, which following case is equivalent. So A, polarity opposites, right? Polarity is opposite. Given voltage value is same. So no, A is not equivalent. How about B? Polarity opposite to the given, and the voltage value also has opposite sign. So this is the correct answer, or say the equivalent case. C, we have same polarity as the given. However, the voltage value has negative sign here. So C is not the equivalent either. The last one is the power sign, and this also matters a lot. Okay. So first of all, to find the power of one element in the circuit, what we need to do is just figure out the voltage across it and the current through it. However, since we just talked about the voltage polarity and current direction, we need to be very careful to choose the correct voltage and the correct current to calculate the correct power. So the voltage, we need to make sure the positive polarity is at the same terminal that current entering the element, and then times the current as it is. This is trying to follow so-called passive sign convention, very important. Some examples down here, okay? So first case, we have positive polarity here for the voltage, and the current is flowing into this positive polarity as well. This case matches the passive sign convention perfectly. So we just directly use the given voltage and the current values to calculate the power. Positive 10 times positive 2 equals to positive 20 watt. Second case, we have a positive polarity of voltage here. However, the current is entering the negative polarity of it. So what we can do are actually two things. We can either flip the polarity of the voltage, or we can flip the current direction so that the current flowing into the positive polarity of voltage happens. For example, here, if we flip the voltage polarity, then make the positive here, negative here. What we need to do is make it equivalent, so we have to add a negative sign in front of the given voltage. And in that way, the positive polarity has a current flowing into. So we can use this negative 10 times positive 2 equals to negative 20 watt as the result. Case 3. We have positive polarity here, and again current is flowing into the element from the negative polarity, so we can flip voltage polarity again, make it to be like this. So we again need to add a negative sign in front of the given voltage. So we need to use negative 10 volts times positive 2 ampere, negative 20 watt again. Last case, positive polarity of voltage here, negative here, and the current flowing into the negative polarity of the voltage. So we need to flip the voltage by given negative sign in front of the given voltage of 10. So we end up with negative 10 times negative 2 ampere, ending up with positive 20 watt. Of course, as I said, we can do another thing, which is flip the current direction. Taking the last case as an example, we have a current flowing into the negative terminal of the voltage. We can flip the direction of the current, make it flowing into the positive polarity of the voltage by giving a negative sign to the given current. So eventually the current becomes positive 2 ampere. Now we're using positive 10 times positive 2, ending up with positive 20 as well. So again, as I said, we can either flip the polarity of the voltage and give a negative sign to the given voltage value. Or we can flip the current direction and give a negative sign to the given current value. Same thing. But don't do both.